So in previous lectures, we talked about the process of going straight to the third normal form by looking at the table definition, the primary key. So if you can isolate the table has only one primary key and there's no other candidate key, you're pretty much into the third normal form already. And the text will give you examples of how do you go reach from one form to another from the original set, starting from first normal form, second normal form, and third normal form. And the more normal form you identify, you will one thing you probably observe is more table you generated, right? More, and the table become narrower, less column in one particular table, but they are related by the insertion of a foreign key. And there are alternative methods to do the normal form. And usually people learning the normalization will go through the so-called step-by-step process. But more likely in practice, we'll go something called a straight to BCNF normal form by looking at a table, identify the primary key and put them into multiple table and link them together with the so-called foreign keys. So in this case, very quickly, SKU data, you go straight from SKU data and buyer. And later in chapter 5 and chapter 6, when we talk about entity relationship diagram or conceptual modeling, and also for those of you who are already working in the database for a while, you look at this table, a natural tendency or natural response to design a database is by identify the independent concept into its own table. So in this case, SKU data seems to be some sort of an inventory concept, and buyer is another like physical people type of a concept. So they are naturally divided into multiple tables. So earlier in previous example, we look at the repair and equipment physical object, repair events. So they're naturally separated. In this case, SKU data is more like a physical thing, and buyer is the people. So physical people naturally identify as different entity or different classes. So each entity or classes will become its own separate table. And this becomes very apparent when you work more and more. You will see that there is a junction or the nature tendency of words seem to be colliding together and become systematic. Either you go from the mathematical perspective using normalization theory, or using a perception or a cognitive processing method from human mind looking at the world, perceive different type of people using entity relationship concept. So entity relationship diagram, conceptual modeling, or normalization, both of them will reach similar database design. Right? So that's something that you will find later will merge together. But here we look at the database design from normalization theory, go straight to BCNF. And once you get into the third normal form, the next job to do is to identify this called a multi-value dependency. In chapter 3, the notation to represent multi-value dependency is using this double arrow. So you have two arrows combined together to represent, okay, one column will identify multiple value of the other column, but they also depend on each other. So the first example, employee degree. So employee can have bachelor degree, master degree, PhD degree. So if a person has more than one degree, you identify employee by employee numbers or name. You have multiple results here. And employee sibling as well. And the typical example, and usually I use that in a classroom lecture, is ask my student to look at your Outlook contact list. So if you look at your phone number, or you look at the Google contact list. Now, one of the problem in the actually older version of the Outlook is that it has a limited set of phone number you can enter. right? And this actually happened a lot in many databases, including a lot of this customer service bank system. You can enter only like a 3 phone number or 4 number max. You cannot go over 4 phone number. If you have more than 4 phone, believe it or not, it's very likely I do have more than 4 phone number in use today. Today, if you count the number I'm using every time I switch the cell phone, that sort of thing. Every time I change office, I got a new. Even now, the rounding number I have, I think I have 5 in the United States and 2 in China, 1 in Taiwan. So I have immediately 5 working phone number right now in that can reach me. So this is why I give you my Google phone number to make sure that you can reach me through the Google phone number. But anyway, so that phone number is a multi-value column in the way that if you treat my personal record of each person's record contact information as a table. So this phone number become a problem. If you put this phone number in a spreadsheet, try to imagine. I don't want to kind of switch back and forth to a spreadsheet. So how do you enter more than one phone number on a spreadsheet for a person? So the first column is first name, last name, phone number number 1, phone number number 2, mobile phone number. The more number you have to use more column, right? So how many columns you want to put into your table? 10 columns or 20 columns? If you put 10 columns, yeah, maybe 99% of people has less than 10 phone number. So you cover, but what if a person has more than 10 number? Then you go beyond that. So there is no limit of how many number you have, so that create a problem of database design. And this problem is called a multi-value dependency. A table has more than, you need to create more than one column to represent that particular concept. In this case, phone number. Solution very simple. Separate phone number into something what we call a dependent, ID dependent table or weak entity conceptually. And you separate that phone number into a separate table, you can create an unlimited number of occurrence of your phone number. It's called a forced normal form. Right. And let's see if I can find an example. We cannot have example here, but so use that concept. You put contact into one table, phone number into another table, and every phone number you put a contact number or contact name to associate the contact and phone number. That design will create a naturally forced normal form design. So once you reach forced normal form, again, like we talked about, you pretty much satisfied the relational database design. So this is a summary that you can go from table, first normal form, second normal form, third normal form, BCNF, and finally reach fourth normal form. And fifth, DKNF, we are not going to be talking about. By the way, domain key normal form or fifth normal form are related to the two other database integrity we talked about. It's called domain integrity and entity integrity. To protect those two integrity, you have to look at the range of the data value and to prevent the anomaly. To give you a very short example to conclude our discussion on the different type of normal form is domain key, domain, right? So you have to if you want to understand domain key normal form, you have to understand what does that mean by domain. And I'd like to use an example to help you understand some of the more difficult concept. Domain in data theory refers to the set of the value a particular attribute or a particular column can have. For example, if we have a column called weekday, what is a weekday? Weekday is not date. Date is from the first day of the month to the 31st, if you have a larger month. And weekday is what? Monday, Tuesday, Wednesday to Sunday. So Monday to Sunday, the 7 combinations are the value possible for weekday. And these 7, the set of 7 value is something what we call domain. So if somebody enter uh, not if you have a column that it says weekday, and then if somebody entered not Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, instead this person enter every day. Every day now is not in a domain, but it's possible. Is it possible that you can enter every day in the database? So, so if you imagine that you try to record a sales happen on Monday or Tuesday or Wednesday and Friday or Saturday, and somebody just typing every day, uh, how do you analyze that data? That data is wrong, and that is called a domain problem, domain integrity problem. And domain key is actually a normalization method to try to avoid the domain inconsistency problem. That makes sense, I hope. All right. So that's pretty much end of chapter 3, and we are moving to chapter 4. And I'm going to be using 20 minutes to summarize what chapter 4 is all about. Chapter 4 talk about the application of normalization theory in database design and how are we going to be using it. First of all, SQL language is the tool used in the job we do in chapter 3 and 4. And actually, let me repeat the assumption of these two chapters. The textbook introduced normalization under the assumption that you are redesigning the database. You have Excel spreadsheet, you move them into Oracle or SQL Server, and in the process, you have to redesign your data table. That job we're doing here. So your job is moving data from one table from your Excel spreadsheet, and you have already experienced moving the data and import the data to a database, right? So when you download the Sam's Club member table and you import into Oracle database, that you have one table, and that table is not normalized. It's probably coming, and you can import the Excel sheet, spreadsheet as a data set as well, like what you doing in your current assignment. So once you have that table, you want to design that into an operational database, then you have to do something. And checking integrity is one. So the first thing that the textbook chapter 4 is trying to tell you is that before you do anything to redesign, check the integrity of your existing database by using query. Now, chapter 4, we introduce a few simple query to help you check the integrity. The first one is try to use count. Counting is probably, this is why in business we call it counting. Counting, believe it or not, very fundamental but most useful data quality control tool. So you count before you move the data, and you count after you move the data. They're supposed to be the same, right? If you count before you move the data and you import the data into your new database, and you count again, they're different rows. There's something wrong. And this is why that in some of our tutorial earlier before we enter the chapter, you see that I ask you to check the result of your import after you move the data, right, from a script to the database, and I want you to check how many record is imported. And this is the query you can count. So use it often, especially during the process of you moving data. So make sure you count it. And this is also the same logic used in internet communication. The so-called packet exchanging mechanism. So the internet, how the internet is designed, is also counting the packet. Make sure that every packet sent out by the server will reach the client, and 99% usually will be good enough for voice and visual communication. But for data communication, you want to make sure it's 100% correct. So that's so counting is one of the basic data quality check, and so that's count. And there are other, typical report and query you can also do and verify. And a lot of time we verify this. Usually we imagine what kind of data problem we have. One of other database problem is called incorrect value, right? So earlier we talked about Monday to to Sunday. What if you have this age, a column called age? If you have a column called age, then you have to, and this age is usually starting from 0, you was newborn, 0 to maybe 200, right? So if you see a record go over 300, for a human being, that's kind of weird, right? So indication of some data quality. So a lot of time we use extreme value, maxima, minima, or top in this case to verify the extreme value. Or in the example of age, it cannot go beyond 0. It cannot have -1, -2, go back in time. Impossible. So that's the thing we can also do. So use the function. You can also check the data quality problem. Now, in this example, I also show you some of the things that from the textbook, the function they use in textbook will not work in our Oracle environment. This is another example. So SQL Server, Microsoft SQL Server has this very useful function called top, or the other one you have used is called the table sample, right? So you can sample a table, collect 25,000 record or rows to sample it, but those are not in Oracle. So when you use Oracle, you want to find top 10, you cannot do it. You have to somewhat using another way. Then in this case, you have to sort, and then this is actually incorrect, but you can use a row number as a keyword in Oracle database that you can use to filter or actually to achieve the same thing. Right? So this is top 10 row can be identified or replaced with a row number statement in the where statement in Oracle. So the first query is SQL Server. Second query is Oracle. Right? So that's what this slide is all about. And you can check the validity, the integrity of the database by using subquery. So subquery is generate one set of data and compare with another set. And you see this logical operation in the query under the where statement. Basically, is compare one set to the other. And if you read this correctly, you know that this is the way we can check the integrity. So this is a preparation before you move data. You check the integrity of the data set before you move. And of course, you have to come up with some sort of a rationale what to check before you start the checking process. Right? Then after you check the data, you can actually do other operation by insert. If you go into the textbook, they will show you how to create a table and insert the data into a table using query. And those introduce additional statement in SQL language. So at this particular point in time, we have extensively learned the select statement. That's only one statement. Each statement is kind of like one sentence, right? So you only learn one sentence in SQL. There are other sentence, create sentence, update sentence, alter sentence, drop sentence, and delete sentence, and truncate. A lot of different sentences in SQL language. These create, insert will be used for database redesign. And after you learn or look at the query, which we do not have exercise to force you to practice, and you should be doing this by yourself. If you read the textbook, you can type this into your environment, Oracle's or SQL Server, try to see how the system responds, and try to figure out what is the consequence of every statement you're creating there. But for the discussion of database management, let's move into more important concept in chapter 4, which talk about the two different design concept or two different design perspective from database. And one is called the updatable database using your textbook's terminology. And the other is called the read-only database. Right? So there are two types based on the division of your textbook. Updatable database, read-only. But in practice, usually people will call this operational database or transaction management database for updatable. Using data warehouse or OLAP database for read-only database. OLAP stands for Online Analytical Processing, OLAP. You probably encountered this terminology somewhere else in MIS 513, maybe, Introduction to MIS, OLAP. And the counterpart will be OLTP. OLTP is Online Transaction Processing. OLAP is online analytical processing. Let me write these two terminologies here just for you to compare. So you see that I'm typing two blue words. It's kind of small compared to the screen size, but OLTP versus OLAP. These two are the terminology usually used in business intelligence system, right? Something that we build report. You have OLTP report and OLAP report. And OLTP, online transaction process, usually refer to the database you try to study, analyze, that is in operation, still running, and people are still creating transaction in their real time. So the example I like to give you most is if you are into the stock market in Robinhood, every day you check on your Robinhood account, then you look at the stock price going up and down. That is OLTP, right? That's online transaction processing report. So you're looking at a dashboard in Robinhood to monitor the real-time changes in your operational database. On the other hand, if you are trying to analyze the sales in the last year from Walmart Corporation, and you need probably go into another big database. And earlier we talked about this performance problem for such a big database. And if you want to generate that annual report, quarterly report, usually you are looking at OLAP type of operation. So it's corresponding to the updatable versus read-only. So OLAP is read-only, and some people will call this a data warehouse or just simply large pivot table type of analysis. Right? So one is read-only, the other is operational. That is, I think, my key here. So when we design the database into the updatable or read-only database, and each one of them has the advantage and disadvantage. And before we move that, let me try to kind of connect these two slides a little bit. Normalization theory usually generate, and the purpose of normalization theory to sort of refresh your memory from previous lectures. There are two main purposes. One is to make sure data integrity. We've been doing a lot today. The other one is try to make sure there is no waste of space, more efficient, no duplication, right? No duplication, no anomaly. And it is a better design for operational database or so-called updatable database. So the advantage of using normalization, or the purpose of normalization, is to build a operational database. But if you want to build a database which is read-only and for an analytics purpose, then you do the other way around. We're going to be looking at the next few slides called denormalization. So normalized table, updatable database has the advantage of eliminate anomaly, eliminate duplication. Right? Disadvantage, when you write query, because there are more tables involved, you have to write complicated query. It actually slow down the performance for your query a lot, and because you have to use join. This is somewhere that in undergraduate class, I give them a tricky question that to ask them, what is the benefit of the normalization? And you know, nowadays a lot of students will look for answer from where? Wikipedia. Unfortunately, that Wikipedia has a not so correct answer for this question. They're saying that normalization can increase the performance of the database, which is debatable. Right? So that when students give me that answer, I know that they look up Wikipedia for answer. But actually, the disadvantage of normalization is actually impact the performance and make trouble to the query creation process. Right? Query become more difficult to write, and the performance of a query will suffer. Right? And the reverse side of normalization is non-normalized or so-called denormalized. And I'll jump in a little bit here. But before we get into that denormalized table, let's take a look at this example of how it is done using SQL language. And again, we are not going to be practice in our class or assignment, but the way that you see how the SQL language is used can be demonstrated here. And basically, we are using this insert, the second statement from SQL we are learning. But the insert statement is combined with the select statement. So basically, you are using these two statements, you can retrieve data from one table and insert that into another table. So this is how you move data inside the database using the SQL language. Right. And this is probably more efficient, in Excel, we can of course copy and paste, but how many records can you copy and paste? It's challenging. We all know that if you want to select multiple pages of data, it's very difficult from using your mouse and keyboard. So you need to write a more efficient statement to do that. So this is how you do that in SQL language. All right. And the example and now jump this to the slide. And this one I would encourage you to read a little bit. And basically using zip code as an example of how you want to change or avoid BCNF, and because we want to avoid that in our discussion anyway. So let's jump through. So let's jump through the purpose of read-only database. It's usually used for analytics purpose, querying, reporting, data mining. So why data mining is usually corresponding to data warehouse, and data warehouse is a read-only, and this is why it's coming from. And read-only database use denormalized table, and one of the biggest advantage of that is the performance. And the process of convert or reverse your operational normalized database into a more reasonable report type ready database is called denormalization. And it's not an English word, so if you type this in Microsoft Word, this will be a typo error. So the process is reversed. You have usually normalized table has multiple tables in there. You reverse the process, become one single table, and you can, and this join table statement, in this case, they're joining three tables together into one, kind of merge three tables together into one, and the operation can be done using in this case, it will be an inner join, right? And this is used in our third SQL select statement exercise. You will learn if you have not getting to that yet. It's due next week. So you have a chance to learn this statement. But similarly, you move into a new table, a merge denormalized table by combining the insert statement with the select statement. So it's the inner join statement, and you can customize and combine table. And in data warehouse design, there is a terminology, or actually a couple of terminology you will encounter if you are in data management. One is called star schema. The other is called a snowflake. By the way, Snowflake is this data company that the cloud application service company that went IPO just last week, I think, yeah, this year. And Snowflake actually borrowed from the database design concept. So when you design a data warehouse, Snowflake is a data model that people adopt. And so this is an example of a customized table. You will adjust your table column design by combining multiple tables into a way that you can easily generate a report. That's the customized table design. And we will have to use the denormalization process and the query statement to build the database accordingly. Right? And there's some problem of database design will also be discussed in your chapter 4. Multi-value, multi-column consistency, and we do this by checking, by normalize and denormalize and try to verify to see if you are in the normal form. That can double check and make sure the database is correct. And I'll skip a few slides to get into the right. And these slides are talking about consistent value and are basically present you with a query that we can use. And I'll encourage you to look at those query and try to see if you can use them in your project. Right? So we do have a semester project which will be given to you very quickly in about 1 or 2 weeks. And you need to do a little bit data quality design by borrow some of the query here and do double checking in your project. And I may not have time to verify your final data quality plan, but this gives you an opportunity to use SQL as a data quality check tool. And so this is a data quality problem that you may encounter as actually you should have encountered by importing our previous assignment by downloading the SQL Server database and rebuilding the database in our Oracle server. There is a data quality problem by missing a few columns when you move the data from one database to another. It's actually checked from, this is a previous version of the Oracle Application Express, and there are data, when you import the data, there are a failed attempt. Some value is inconsistent. It fails to be ported to a new database, or maybe the column or the data format is incorrect. And we use a count, try to verify to see if original data record you export is consistent with the data you import. And all these verified checking represent the process of how you use query, use a textbook introduced example to verify your data quality. And one note about the Sam's Club dataset is what I did here is I used the example of verify the membership type. And it does not have a description from the data set itself to describe different kind of membership. But for those of you who have Costco or a Sam's Club membership, you know there are different type of membership: corporate membership, premier membership, regular membership, and some other membership. And so does Sam's Club. And we're looking at the data set and try to see are these membership count make sense or not, right? Regular membership versus all different kind of a membership. This is way use the query language and the human judgment try to verify the data quality problem. And more examples just telling you how to check the quality by looking at original query from original system, which is in the SQL database, and to the new system, Oracle database. So that process described very well. You move data, and that process is also called the ETL process, extraction, transfer, and loading process. And the textbook chapter 3 and 4 talk about Excel spreadsheet put into a database. It is also an ETL. You extract the data from Excel spreadsheet and probably move and send email, load the data, put them into a flash drive, and put into your server and load into your SQL Server database. That process is ETL. And the most important thing in ETL is make sure data are transferred correctly. And you can also do double dip data quality check to verify the data quality before you build a new database. Right. So that's what all about in chapter 4. And at this slide, we pretty much learn and conclude the chapter. There are a few more slides in our module 2B lecture, but those are self-explanatory, and I will stop my lecture on chapter 3 and 4 here by looking at what we have learned so far from this particular slide.